everybody. Today we are debating Flat Earth, and we are starting right now. Ladies and gentlemen, thrilled to have you here for this epic debate as we are very excited to have these two experienced debaters with us today to debate the one and only question, the shape of the Earth. So it's going to be a lot of fun, folks. Want to let you know I have linked both of the debaters in the description. And so if you're listening and you're like, I like that. Well, got news for you. I've put those links down there just for you so you can hear more of both of these gentlemen. And want to say it's their first time here, and if it's your first time here, consider hitting that subscribe button as we've got a lot more debates coming up. So in fact, you will see at the bottom right of your screen, we will have a tag team debate tomorrow. That will have Tom Jump as well as Amy Newman going against two Theas, both of which who will be new. And so that should be a lot of fun, folks. We hope you can check that out. So it's going to be a lot of fun tomorrow night for that tag team debate. And what else I would say is, if you have a question during today's debate, please feel free to fire that question into the old live chat. I will pick out that question. If you tag me with Modern Day Debate or at Modern Day Debate, that'll make it easier for me to make sure I don't miss any of the questions, and then we will ask as many as we can at the end. So we are going to have a pretty flexible format for today, namely roughly 10-minute opening statements, followed by a flexible 50 to 60 minutes of open conversation, followed by Q&A. So want to say thanks so much, gentlemen. Planner Walk and Flat Earth Aussie, it's a pleasure to have you guys for the first time. Thanks for being on here with us.
I'm glad to be on.
Awesome.
Okay.
Really fun. So this should be a lot of fun, folks. We are going to, given that we usually have the Flat Earther go first, Flat Earth Aussie, happy to have you make your case. And like I said, it's a flexible 10-minute opening statement. And do I remember, did you guys make a decision on, you guys are okay with either going first?
Yep.
Absolutely. Okay, perfect. Thanks so much. So, Flat Earth Aussie, thanks for being here. The floor is all yours.
All right. Well, thanks, James. It's great to be here finally. Haven't really watched too many of the debates on your channel, but seen the odd one here and there, so I sort of have a rough idea how your system works. We have a bit of a chat, open debate, open discussion to start with, or opening statement. So, for me, as you know, most people have come across me once or twice before across some of the debate sites. I'm not a professional debater by any means. I'm a writer far more than I'm a public speaker. So I do tend to get a little nervous when it comes to making a live presentation. I've been questioning the nature of reality probably since my mid-teens, as it might turn out. I don't think there's any definitive explanation for the nature of reality. It could well be a simulation for all we know, but we don't know. So we just go with our best evidence. So when I look at the nature of reality, I just look to the nature of physics. And the nature of physics tells me that there are observable laws. You've got solids, liquids, and gases. And the nature of them is pretty easy to understand. The nature of liquids is they will fill their container, they will form a flat and level surface between higher edges of a solid, and if not, they'll flow to a lower level to seek another level. So the nature of water tells me that the Earth itself is flat. There are other things that we're getting into finer detail about now, and that is basically the nature of light itself. This is where we're fine-tuning our understanding of this flat planar Earth we live upon. And the nature of light, I think, is the definitive thing for understanding the nature of our reality. I mean, everything when it comes to science means we basically make observations. The way we make observations is with our eyes, and the way our eyes work is because light bounces off of things for us to observe them. If we can't trust our eyes, then we can't really trust anything else to do with the nature of reality. So when we look at light, we know that basically our source of light is the sun. That's how we get our daylight. But to understand then the opposite aspect of that, the reason we have a nighttime must be because there is something that the sunlight is hitting upon at daytime to give us the nature of light. If not, then there'd only be a tiny shadow of Earth reflecting across, or okay, not reflecting, blocking the sunlight at night time, which would only block that tiny little speck relevant to the size of the planet Earth that heliocentrists believe in. And the rest of the universe would be then teeming with sunlight. But because we know that sunlight works because it's bouncing across something, what that something is happens to be our atmosphere. That's our atmospheric gases. It's the noble gases of the atmosphere which illuminate, much like the gases inside a fluorescent light bulb illuminate because they're electrostimulated by a source. In that case, it's electricity. In this case of our Earth reality and the sun is obviously some sort of electrostimulative force that in the presence, the nearby presence, the noble gases of the atmosphere glow like the interior of a light bulb. We don't need to have gravity to have these gases at their various levels. They will sort themselves out according to density and buoyancy. Every thing has its own molecular weight, and so they will sort themselves out roughly in the form of gases. Of course, it's very roughly. In a form of a liquid, we've got a more defined density, as we've seen in a density tower, but the atmosphere basically works the same way. In the upper atmosphere, we have the two lightest gases that we know as hydrogen and helium. And modern science tells us that the sun is mostly hydrogen and helium. Now, what a coincidence that is. What we're actually seeing when we look at the sun is the apparition of the sun up in the upper atmosphere where it's all hydrogen and helium. And so this apparition glows like, say, a welder's arc lamp, for example. And then the rest of the daylight sort of spreads out from that, but we see this defined point, which we call the sun. But the fact is that upper atmosphere, on the huge scale of things above the planar Earth, a massive, massive planar Earth, which we are just tiny little dots on the surface of, when we put all this to scale, the atmosphere itself above, say, here's the planar Earth, the atmosphere is only like this tiny little amount above us. But to human perspective, it's actually really high. It could be like 50 miles high, since we know airplanes fly 3 to 5 miles high, maybe 6 miles high. To be 50 miles high is actually very, very, very high. We tend to misinterpret how high things are because we're so used to seeing things across rather than high. But you stand at the base of a tall building that's only 100 meters high, it looks very, very tall. Walk down a few blocks, it looks very, very small. It's all a matter of perspective. So if the sun is a roughly 50 mile high above us, what we're seeing is the apparition of the sun through that upper layer of the atmosphere. But the sun itself might be 500 miles higher, 5,000 miles higher. We don't really know. So what this does, it creates a layer effect where, so wherever you are on the planar Earth looking up at the sun, where the sun really is not where you're seeing it. You're just seeing it in the upper atmosphere, which is why if you see the sun from where you're looking at it, somebody 500 miles away will be looking through a completely different part of the atmosphere, seeing their apparition of the sun, which places the sun in two completely different places at the same time. So when you spread this out over thousands of miles across the planar Earth, you're basically going to have, well, every different individual's perspective of the sun. There's 8 billion people. You've got 8 billion different suns. And the same goes for every conscious living thing, whether it be a plant or an animal or whatever, you name it. Anything that can detect the sun is going to have its unique individual perspective of the sun, which means even though there's one source for the sun, there are multiple different variations of where it appears and what it's doing, which is why sunlight is not quite so simple as what the globe model shows us, where you've got one sun 93 million miles away, a spinning ball rotating around and giving you your 12-hour days with your morning and evening type of thing. Now, on the flat Earth, you've got multiple different variations, and the sun is illuminating them all locally. So when what you're seeing is the sun as it's setting and giving you the red spectrum of the noble gases in your atmosphere illuminating the bottom of the clouds for you. From somebody from a completely different location, several thousand miles away, the sun is directly overhead and it's still bright and golden and illuminating the clouds from underneath a bright white spectrum of light. The nature of light itself means we're more or less like on the inside of a light bulb, and the light will be shining upwards towards the bottom of the clouds. Hence why when the sun is so far away and only illuminating the neon gases that give us the reds and oranges and purples and so on, they will still be illuminating the bottoms of clouds, even though from our perspective the sun appears to have set. So the nature of light, one of the more difficult things to grasp in the nature of perspective, is the reason why everything works as we see it on a flat planar Earth. If we were doing it from the rotating ball model that we all once believed in, then the Earth is spinning away as to make the sun set in the opposite direction. And the moment that that sun goes beneath the horizon, it should immediately cast a dark shadow across your entire part of your sky. So you're going to be instantly plunged into darkness, but we can have twilights that go for hours upon hours. This ball spinning at 1,000 miles per hour could instantly plunge into darkness. Going higher on a ball is actually going further away from the sun, according to that law of perspective. Going upwards is going away from the center. You're not going back over the curve to see the sunset again. We see the sunset multiple times as we see if we send a drone upwards, simply because our angle of view is showing what is further away. The higher up you get, the further you can see. We'll leave it at that.
Thanks so much, Flat Earth Aussie. I want to say this is totally my fault, folks. At the very start of the stream, I had trouble hearing Flat Earth Aussie, so I asked him to crank his mic up as high as possible. And so we could hear you, Flat Earth Aussie, but you can probably even turn it down just a little bit, because some of the audio divas out there were like, his mic is so bad. Your mic is fine. It was my fault for telling you that it was too low. So you're coming through perfectly. Thanks so much for your opening statement. And now we will kick it over to Planner Walk. So Planner Walk, a joy to have you here as well, and the floor is all yours.
Okay, so the first thing I've got to say is it's amazing how much taking a few notes, and I noticed that you misunderstood how things work on the globe model. And so, so some of the things that I want to say is, in this debate, I want all claims that are being made to be substantiated in some way, shape, or form, right? So if you make a claim about the noble gases being illuminated by the sun, I want you to be able to substantiate that, because if you don't substantiate it, you might as well just dismiss it, because that which can be asserted without evidence can be dismissed without evidence. And I know that there are a few things that flat earthers will say, oh, this is evidence for the flat earth, like the black swan. But most of these things that are evidence for the flat earth, in fact, all of them would actually has a lot of evidence to the contrary. So you could bring up something like the black swan, but there's Tampa Bay images, or the Tampa Bay blink tests. You've got images which show the oil platforms from the black swan image actually being obscured bottom up and all that kind of stuff. And all this stuff is what would expect to see on a globe. So it's really strange to me how someone like Flat Earth Aussie Jesus can claim that the earth is flat, yet all the evidence that we've got points to it being a globe, and is exactly what would expect to see if the earth was a globe. So yeah, there is that, and I find that flat earthers often don't have a lot of positive evidence. So what I do want is positive evidence for the earth being flat, not just claims of, or not just saying, oh, this isn't possible on a globe, because saying that something isn't possible on a globe is usually just a misunderstanding, and it's not really providing evidence for the Earth itself being flat. It could just be that the Earth isn't a globe or isn't a globe with particular dimensions. So some positive evidence for the Earth being globe my main one would have to be the sun setting. So the sun sets, and you can calculate when the sun should set based on your latitude and longitude. And it also, another important bit is that we have time zones. So I can talk to Flat Earth Aussie Jesus, and it's right now with the sun out. But for a lot of people in chat, they're in night. I don't think that this is possible on a flat Earth, because you'd have the sun still appearing in the sky, no matter how far away you are. It would be very dim at certain times, but you'd still expect to see it in the sky. Just because something's dim doesn't mean that it's unseeable. Another important thing is objects disappear bottom up over the horizon. So you've got things that, like ships, will go over the horizon, disappear slowly from the bottom up until you can no longer see any of them. This is not explained by flat earthers, who will often say that it just disappears from view. But they say that you can zoom back up on it, but this is just because it has gotten too small to resolve. When you zoom up on it, you will then see it start to go over the horizon eventually. And once it goes over the horizon, you will not be able to zoom up onto it to bring it back into view. This is a distinction that flat earthers don't make between whether something is resolvable or whether it's actually gone over the horizon. So then there's also things like images from space, which I know that Flat Earth Aussie Jesus would like to claim as CGI, but I don't think that it's quite possible to make a full Himawari satellite image with the CGI that we have today, because you'd need to first account for all the cloud data being correct. This has been verified multiple times by multiple people who have gone and looked at the sky or gone and looked at the clouds and said, hey, well, these clouds are exactly the same as what would expect as what the Himawari satellites show us. And this would take a lot of effort to be able to put together, especially with the amount of weather data that you need. You need weather data from thousands and thousands of weather stations and all that kind of stuff to just be able to do this. And it's also been able to predict things that, like, I think there was a fire in China that it predicted, and we got data from the Himawari satellite to be able to warn people, hey, look, there's a fire in China. You can do something about this before it gets out of control, because otherwise things would have gone pretty bad. So yeah, there's all that kind of stuff. Then there's the moon landings, which I don't think can be faked. So when it comes to the moon landings, I know that Flat Earth Aussie Jesus is laughing there, but I don't think that it's possible to fake the moon landings, especially when it comes to the technology that was available at the time. You wouldn't have been able to fake moon landings, especially with the studio lights. My challenge to anyone that believes that the moon landings are fake is to go and try and fake your own moon landings. If you think if the moon landings can be faked, it should be very easy to go ahead and make a fake moon landing. So that's my challenge, using the technology at the time. So you're not allowed to use lasers to produce your light. You got to use studio lights and stuff like that. So that's all I've got. That's all I've got to say. So otherwise, I'd be rambling off too many points to discuss in this debate. I think I already have.
You bet. Thanks so much. Really appreciate that opening statement from Planner Walk. And we will now jump into the open conversation, folks. So thanks so much, gentlemen. The floor is all yours.
Okay, well, Mr. Planar Walk, interesting choice of name for a Glober. You asked me if I have any links to claims about nature of sunlight. Well, of course I do. On my channel, which I'm pretty sure James has already linked here, I have a playlist called Perspectives Playlist. And on that particular playlist, I've linked multiple different ones that I found, and there are even better ones since that I haven't found the link to. that show the nature of how noble gases, when introduced to electrical stimulation, such as a Tesla coil, they start to glow, they illuminate. And so whatever the sun may or may not be, it is a powerful source of energy that causes the gases to illuminate, and that's what gives us daylight. For example, in this room right now, there's no direct sunlight coming in through any window. In fact, it's a very overcast day, and yet this entire room is still lit by daylight. It does not have to be a direct source of light, because the entire atmospheric gases are glowing, and that's what daylight is. It's a different source from direct sunlight, which will create a direct shadow. There's nothing actually creating shadows in this room at the moment, but the daylight is still illuminating the entire room. So there's plenty of evidence to suggest that the atmospheric gases are the cause. Well, they're not quite the cause. They're both the cause and the effect of light, but they are not the direct stimulative force. They're the result of the stimulative force, and they are the cause of light. So it's, everything is a three-way relationship, no matter what you look at. With everything, you've got your cause, you've got the effect, and then you have to have the observer. And without the observer, it's like a tree falling in the forest. It doesn't make a sound. Well, the sound might exist, but without somebody to hear it, the sound didn't really exist because of nothing to detect it. And the light is the same sort of thing. It creates. You have to have the observer, the intermediary, the medium that it causes in, and then the source that causes the effect you see. Everything is a three-way relationship. So I'd like you to hear your explanation for the nature of light.
So when it comes to the nature of light, light travels it's argued whether light travels as a particle or a wave. But the thing is, when it comes to light, it does bounce off surfaces. And it can also be refracted and all that kind of stuff. So you've got Rayleigh scattering, which will scatter the light throughout the atmosphere, which causes the sky to appear blue, stuff like that. And so that can cause light to reach places where it normally wouldn't reach if it didn't have any kind of scattering. Then you've also got it bouncing off surfaces. So in my room that I'm in, there'll be certain places where it's darker, certain places where it's lighter, and sometimes there's even a bit of a gradient on the wall as to from dark to light because of the way that it bounces off surfaces. There's less light reaching that area. This isn't because of some noble gases or anything, and I'd be interested to see if you've got a link to any of these things which actually would prove that the noble gases are being illuminated in the atmosphere by the sun. Do you have any evidence for that?
Well, yeah, as I said, it's on my perspectives playlist. I'm not going to access those links right now while we're having this discussion. Anybody can go and look for them themselves. You're quite welcome to have a look there. There's a whole list of them, and it shows how when you have these gases in a test tube, for example, a sealed tube, and you bring them closer to the electrical stimulative force of, say, a Tesla coil, they start to illuminate and glow. And you can bring a powerful magnet underneath them and move it around and show how it creates a solid field of light, very solid, which is more or less what the sun appears to be to us, because it's something you cannot see through, but we can see through daylight. So,
can I ask you a question?
You can ask me a question, but that is a question.
So, true. So when it comes to these gases in a tube, how much of the gas in the tube is a noble gas?
Oh, I'm not sure about that. I didn't do the experiments personally myself. All I'm saying is that somebody has collected these particular noble gases into a test tube, and I would assume it's a fairly high percentage for them to illuminate. If you just had a glass tube full of air and put that near the source, it's not going to light up, is it? So, to create just like normal neon street lights that we see, in the neon tubes that businesses use, that's because they're filled with neon gases, and depending on which amount of the gas and the amount of electrical force you put into them, they glow like bright lights, especially in darkness.
But that kind of debunks your point. If you take a tube full of regular air and hold it up to a Tesla coil, it's not going to glow. So why would it glow under the sun's
Because it's
energy?
not just regular air in our atmosphere. Our atmosphere is composed of a huge range of gases. And some of these, what they call noble gases, even though they're only a tiny percentage, they still exist at their particular bandwidth that they exist at. And that is where they glow, nearer to the sun, which is why the light being up so high tends to be something we don't see blinding us in our face, because it's up really high and it creates the daylight effect.
But you've also got the atmosphere at high altitudes being very, very thin. You do know that, right?
Yeah, that's exactly right. That's why, like, helium, for example, is one of those upper atmosphere gases, helium and hydrogen, because they are so less dense than the other gases that they tend to rise to the surface of the atmospheric level, which is where we see the apparition of the sun in the first place, and then the resultant light that comes from it in the other noble gases, which is why when the sun gets further away, the neon gases show us those reds and oranges, which reflect in the clouds to give us the lovely sunset colours.
But you still got to account for it being a lot thinner. So you'd have to go ahead, and one of the things you'd have to do is work out how much light you'd be getting from the noble gases that are high up. And that's assuming that what you're saying is correct about the sun being a giant Tesla coil. And you'd have to go, okay, well, they're this thin and would produce this amount of light. This is not, I don't think that you have any data on that, do you?
No specific data, no, because we can only send a helium balloon up so far, which is roughly the 23, maybe maximum 25 miles of height. And that is generally where, if it's near enough to the sun, you'll see the sun is not very much higher than that at all. So the sun itself might be no more than, say, 30 miles high. The actual apparition of the sun that we see, as I said, there's the real sun, the real source, which could be any unknown number of miles further up, which it obviously is to create the seasons. The further away it is, the smaller the circle it appears to make above us. And as it gets nearer, it appears to make a bigger circle, hence why the light spreads out more on the outer or southern side of the equator. So the light source itself is still creating direct light through the least amount of atmosphere, which is what even creates the seasons. So it's actually quite a logical explanation for seasons on the planet.
Yeah, so let's rewind a bit, because you mentioned putting high altitude balloons up into the atmosphere. When you see the footage from them, they show a black sky.
Yeah, because they're already above the layer of the neon gas or the noble gases. I think it's actually argon myself that creates the blueness of the blue sky. So it's already gone above the blue. You can still see the blue haze below it.
Yeah. So do you think that if you were to grab a sample of, somehow grab a sample of the atmosphere up there, right, and put that into a test tube and then illuminate the test tube, that you'd have, do you think that would, or you put a coil near the test tube, do you think that would make the test tube glow?
Hard to say. I'm not sure what's up there. But I think there could be some inert gases in between, say the argon and the neon, which creates the colourful parts of the sky. And then you've got further up higher the helium and hydrogen, which creates the bright white apparition of the sky. There may be something inert in between. I couldn't say. I've never tried it. It'd be interesting to try. I'd like to see somebody do it, but who would know? Maybe it is going to be bright enough that if you brought it down and put it within the vicinity of a strong electrostimulative force like the Tesla coil, maybe it would glow bright white like the sun. It's a good question.
Yeah, so you don't actually have any evidence for the for any of the atmosphere being able to be illuminated by the sun.
Well, apart from visual evidence of everything we see and the nature of daylight, no, nothing more than that.
Okay, so let's move on to something else, because one of the things you...
Well, before we do move on, you were the one that mentioned the black swan, of course. I didn't, but you brought it up. But you mentioned the fact that light might curve around something, and that then light could also reflect off it, and somehow this reflection of light is going to bring a physical image of something higher up above the horizon. Would you care to explain that for us?
Yeah, so light can be refracted by atmospheric conditions. And
Yeah,
there was
light can, but what about the physical apparition that it's illuminating?
What do you mean?
Physical object. The physical object, say, of an oil platform way beyond the curvature of your horizon. You were saying that light can bend up from it, but how can the physical appearance of something solid also come up with that light? I mean, does light create a hologram or something that's beyond the visible range of view, beyond a physical curve?
So I've got a question. Do we see actual objects or do we just see the light?
Well, so far as I'm concerned, this is where I'm getting at, is you're making a point that light bounces off things. I'm saying it doesn't. I'm saying light illuminates things which are there and we're seeing what is there. Light is not a force of something that's moving, bouncing off stuff, refracting, doing any of this stuff. Light just reveals what is there to be physically seen. If you can't physically see it, then it's obscured by something physically blocking it, or it's too dark to see it. It doesn't do these magical things that the globalists are trying to suggest that it does. It can raise things up behind something that is a solid object obscuring it. Light does not do that. It might bend around it, but all you're going to see is the light. You're not going to see something that's hidden from you.
Okay, so question: I didn't hear an answer in there. Do we actually see light, or do we see physical objects? Like if I have a physical object here, am I seeing the light that would be bounced off this, or whatever you want to claim that's been happening, or do I actually see the physical object that I've got right here?
You do. You see the physical object because the light allows you to see it.
Okay,
but you're not seeing the light necessarily. It doesn't work like that.
So what if I had a something like a hot thing right here that was producing a lot of heat, made everything wavy? Would I still be seeing the physical object, or would I be seeing the light that's being refracted from wavy air?
You might just see some distortion because of the wavy air reacting to the heat, but you'll probably still see the object if you held it up. When you hide it below you, there's not enough light to reflect off it for me to see it, is there? It's obviously obscured below the limits of my range of vision, or the camera's range of vision.
So if I have wavy air, does this mean that this has suddenly started becoming wavy, or am I seeing a distorted view of this?
You're seeing a distorted view because the air is between you and it has become wavy.
Correct. So when it comes to things being refracted, we're not actually, it's not that these objects are actually physically being distorted or anything. We're seeing distorted images because of things like atmospheric conditions. So when it comes to the black swan,
but you're not going to see the toilet paper raised up into the air because of wavy conditions in front of it if you've moved it out of the field of view of the camera.
You might have certain effects. I've actually got this great video by Mick West which shows, I think it's, can I screen share? Okay, so if I just share my screen, apparently I can't screen share.
There should be a small green box at the bottom, but let me double check just to be sure that you're for sure able to access it. So usually either on the side or on the bottom, there is a small green box that has like a arrow vertically pointed upward. And
it says host disabled participant screen sharing.
What? Okay, let me see what I did here. Sorry about that. I've had like a ton of Zoom meetings lately. Thought I might have accidentally done it during one of those. We're going to find this. Sorry, folks. But I would remind you, folks, both of these gentlemen I have linked in the description. So if you've enjoyed what you're hearing, well, now's a great time to check out their links in the description. And I am pulling up one participant can share at a time, multiple participants share. Hopefully that maybe helped.
Okay, there we go.
Awesome.
So what I've got here is I've got this video, and it's by Mick West, and it shows the Black Swan images, and he's applied refraction and shown how refraction would create the images that we see in the Black Swan, in the Black Swan images. Do you have any thoughts on this, Flat Earth Aussie Jesus?
I don't know what you're even trying to say here. The horizon is still visibly well beyond the platform, which should be hidden by possibly hundreds of feet of curvature.
Well, this is a simulation right here.
Right.
So this is showing.
Oh, okay. The curved bit.
Yeah. So this this line that he's got here, that he's got his mouse over, this shows the the temperature of the degree or temperature of the air, and you can change this to modify it to change the refractive or how the air refracts light. And he's actually managed to simulate how the air should be refracting light in the Black Swan images to pretty much recreate the Black Swan images in a model.
Okay, well, if you want to hear my thoughts on it, I'm looking at the circular image in the top left where you've got the bend. And so far as I'm concerned, where the viewer is, you're going to have a straight line coming out from line of sight, because that is what horizontal means. And that second platform should and would be completely hidden if there was curvature there. There's obviously no curvature because horizontal always brings everything to eye level. It's simple as that. Convergence works by lifting everything. Well, it's not really lifting. It just appears to ramp up until that convergence point, which always matches eye level, depending on the viewer height. And from what I understand, the viewer height of this image is only a foot or so above the water. So there's no way it should be ramping up that far due to normal laws of convergence, even, unless obviously the water is perfectly flat and level and you just had a very clear day. Be able to see
so a few things to note there. So it's kind of hard to see it, but this actually shows a lot of lines coming up from the observer's point of view, and most of these lines are curved to indicate that there has been that the light reaching the observer has been refracted. So you see this big curve here, and then you also see a lot of lines that are curved, that are curving down this. And this shows that, yes, there is some refraction, or this is how the light is being refracted. And it's, I don't know if there's also it's got a comparative image. So if you see this image here that I've brought up on screen, this is what the Black Swan actually looks like. And then you go to the simulation. I'm just trying to find where I had it before. When you go to here, it shows an image that's very similar to it. Obviously, it's not exactly 100% because this is in a computer program and the other one was taken in real life, but it shows how you'd expect to see the image using things like refraction to account for it.
Okay, well, look, I'll be the first to admit that I'm a flat earther. I'm not keen on the word refraction at all. I actually think it's a load of bollocks. I don't think there's any such thing as refraction. I think what you see is what you get. You might get some mirage effect quite often, depending on the circumstances. But this whole idea of refraction, being able to lift up the visual view of a physical object from beyond a physical object, is just bollocks. It's like if you want to do it in reverse and say, okay, there's a tall building in front of me, somebody's gone behind that tall building, but refraction is going to bring an image of that person from beyond the tall building. You're just doing it 90 degrees and saying it can go upwards, but it doesn't go left, right. I just think it's absolute bollocks. And because this Black Swan thing is not my thing at all, I don't even want to discuss it. I think we should go straight on to your next point that you brought up, which is time zones, and how you can't comprehend how time zones could work on a flat Earth, even though you think they should work on your spinning ball in outer space. And it's very, very simply described by the sun is local, nearby, and it goes around us above the equator, and it takes 24 hours to come back to where it was. So the sun is basically the hour hand of a 24-hour clock, and wherever it's directly above is your local 12 noon. So if it's directly above you, it's 12 noon. 2 hours to either side, or whatever the distance is for time zones, then it's going to be 11 o'clock there and 1 o'clock there. And then as it moves around, it's going to be the local 12 noon, while the direct opposite side, the other side of the North Pole in the middle of it, is going to be 12 midnight. And that's how time zones easily work on a flat planar Earth. So to say that they can't work on a flat Earth, tell me why that can't be possible.
Okay, so the problem isn't so much with time zones themselves. It's more that you've got you might have someone like me in New Zealand, and then someone over in America. Let's say someone in New York, right? And someone in New York would have. I'm pretty sure it would be quite dark outside, and I'm pretty sure there'll be many people in chat, or even maybe James. It looks like it's quite dark where you are. So when it's dark where someone is, they should be able to look outside, and if the Earth were flat and we've got time zones, they should be able to go, oh, well, the sun is over there, right?
Yeah.
And I've actually created a few models to show how the sun should be circling around the Earth if the Earth were flat. And it does not line up with what we see. In fact,
well, I think like the trouble that you're having with that is the sheer size and scale of the actual Earth itself. It's massive. It's really, really big.
I've accounted
anytime
for
you
that.
try and scale something, it's going to be, you won't possibly be able to do it in any physical model on any sort of computer. But by the time you got the sun to be the size it should be according to scale of the real and actual Earth, it's going to be too small to be even able to be seen. I mean, just for a normal local perspective, where we see the sun disappearing beyond our horizon, which is only like about 3 miles away, 5 kilometres, that scale alone to put on a screen means that we're 1 millimetre high to a 3,000 millimetre screen distance. So to try and put that under a scale model, it's not going to fit even into a screen just for your own personal local perspective. Now, if you try to put that then onto something the size of the Earth, you will never, ever, ever be able to physically model it. You have to cram too much information into too much size that it won't make sense, because our brains are actually capable of enough of making sense of things according to how we know we see them. But you can't do that in a model. The model is reality as we see it at full scale. And
so
let me try to make a model. Yeah.
So let me show you this 3D model that I've come up with on my computer. It's
Sure.
So just bring this up and share this. Here we go. So you see this?
We still got black.
Okay. If I go like, is that better?
Still a black screen, but I do see that a video looks like it's like ready and able to be played.
Okay. So in here we've got this video which I created using Blender, and it shows what the sun would look like from ground level, and it's got the sun, which is this small ball over here, and it shows what it would look like. So it's currently evening, and now it's night as it goes around. So even during night, you should be able to see the sun.
Yeah, well, then you clearly don't understand the scale of the size of the Earth. I mean, we can't see Polaris from the point of the equator further outwards. The point of the equator is where have you taken convergence into effect? Or are you just looking at it as flat without convergence?
I've taken a lot of things into account here. So things that I've taken into account was the I took into the account the size of the Earth. So the Earth in this model is, I think it's
Do you
about.
understand what convergence is?
Are you talking
you
about
underst-
perspective?
It's part of perspective, absolutely, yeah. Convergence means that everything that's beneath you appears to ramp up to eye level, everything above you appears to ramp down. So this is,
Yeah.
I don't know if you've ever seen the Freemasonic symbol, this one here where they got the compass and the set square. The reason it's called a set square is because it's flat and level. The model always says always on the level. But this, from down here, when your point of view, the set point appears to rise up to eye level. The sun, on the other hand, because it is so high, appears to take a pyramid line. And that's why it appears to go up and appears to come down while always being on its own level, parallel to the ground. This is perspective. You cannot put two models, this and this, together unless you can grasp it in your mind how perspective, convergence, the appearance of things all actually work. This is why a model will never work, because you're either doing this one or you're doing this one, but you can't do both together because it just ends up being.
So you do realize that 3D modeling softwares are always designed to account for perspective, to account for convergence, right?
But are they taking it from the point of view of the viewer, or are they changing it to be the point of view of the person looking at the screen instead of where the viewer actually is over here? That's the problem. The viewer's point of view is never taken into account for his convergence. When you're looking at it straight on, you're not seeing how he looks at it, the visual point over here. You're seeing it like this again. And that's not how this person is seeing it, which is what we're seeing it from, when we're back into that field of view looking outwards.
So
There's a
when it comes,
convergence.
so there's a simple equation for perspective. Do you know that equation?
No, I don't know that equation because it varies with every different height variable.
No,
There's
it
no
doesn't.
equation.
There's a simple equation. It's basically, I think it's arctan, the arctan of the height of an object divided by the distance to that object.
And you want to put that into English? Because I don't understand mathematics.
So basically, it says that's the formula of for perspective. And basically, what it does is it gives you the angular size of an object, depending on its distance and its size.
So it's a distance diminution formula. Is that what you're saying? Why it shrinks so much?
Yep.
Yeah, but that's got nothing to do with the convergence factor as well. They
Yes, it
both
does.
have to be taken into account. You've got convergence plus you've got distance diminution.
So convergence, you can basically take the way that you can work out convergence is you can take the distance to the object, right, and then the height of the object compared to your eye level. And so instead of so if you want to take the sun, right, the sun would be, just say the sun's at 1,000 miles high. Then you were to take the distance. You'd take the distance to the sun, and I've worked this out, but I can't remember the exact values that I used. But I took the distance to the sun and the height of the sun, and when I plugged it in, there should be a whole 7. I think it was 7 degrees that the sun should be above the horizon. When it's at its furthest.
I really don't like when you start using degrees either. Simply because, okay, we take a simple protractor, and that protractor represents 180 degrees from one side to the next. But if you made that protractor much bigger, then the distance between each degree gets bigger and bigger. But so when you start talking about degrees on something where you've got a 8,000 mile big protractor, and each degree has 69 miles between each one at the very end, our minds can't really grasp it when you're talking about thinking degrees. If it's 69 miles, so you're saying 3.5 degrees, well, what's that? About 25 times. It's.
But we're not using. But the problem,
you're using degrees as though degrees are only these tiny little things, but they're not. When you put them to
yeah,
true
that's my
scale
point.
on the Earth, they're massive. They're massive, massive. And so you're obscuring reality by calling it degrees.
No, I'm not.
You just used real distances. Like real distances, if you say if something's 7 degrees difference, 7 times 69, well, 7 times 490, so it's 490 or whatever it is, miles difference. But saying 7 degrees makes it sound tiny.
Because using distances like kilometers, like saying that the sun should be 1,000 kilometers above the horizon, that's not going to make any sense, because if it's 1,000 kilometers above the horizon and it's right above you, then that's a lot different to saying that it's 1,000 kilometers above the horizon and it's 20,000 kilometers away. That's a huge.
Exactly, and that's why the distance diminution thing also means the gap between things change, and that's why that symbol shows the path, the apparent path of the sun, as opposed to the actual path of the sun being dead straight across us, because we're looking down from this very low perspective point where our local horizon is only 3 miles away either side of us, where the set point is, the set square. And so to see the sun go up and down when it's going like this and then disappear, you cannot put that into a contextual visualization that makes sense if you're looking at it with this 2D geometry sort of thing from the side on. It just does not make any sense.
When it comes to degrees, the reason why we use degrees is because it takes into account it basically takes into account how far away something is, and well, we can take into account how far away something is and how high it is above the ground. So when I say that the sun is 7 degrees above the horizon, right, this means that it will be above the horizon visually. And if the sun gets, whereas if I say that it's 1,000 kilometers above the horizon, then it's like, okay, but how high is it above the horizon when I look at it? Because if it's 1,000 kilometers above the horizon, it could be above you, it could be far away, and you wouldn't really get an idea of how that looks. When you say 7 degrees above the horizon, then you can plug that into things like 3D software modeling programs, or and actually get a visual representation of how that should look.
It's exactly the same thing, because when your horizon is going away from you to the obscurity point where things get vanished, even the clouds, they might only be 3 miles above the surface, but they will be visible because they go so much further across. They're visible another 30 miles away. So by saying that they're only 1 degree above the horizon, as a visual thing, it still makes no sense. They're still actually 3 miles above it. Same as the sun, if it's like 50 miles above it, it's still going to be above it. It just won't appear to be that way. So whether you call it degrees or kilometers or whatever you want to call it, it makes no difference, because it's a visual effect when something disappears into the distance. You'll still see the clouds meet the horizon, but the clouds aren't bumping into it or hitting it. They're still the same height above it the whole way. And you can see that they're flat and level the whole way too. So when obviously that must be parallel to the ground.
So when it comes to why we use degrees to work out, okay, how should this look? So if you've got if it looks like the clouds are meeting the horizon, so just say you zoom up on the horizon and you can see clouds pretty much touching the horizon, you'd say that there is 0 degrees separation between the ground and the clouds when you look at it. Now you can go ahead and work out taking the clouds at just say 3 kilometers height and working out how far away the horizon is, or whatever you want to do, and work out, okay, this is how high the clouds should appear off the away from the horizon using degrees. You can't say the clouds should appear 3 kilometers above the horizon, because that wouldn't make sense.
Yeah, but either does using degrees, because a degree on the size of something that you claim the globe is 69 miles. So if you're saying it's 7 miles, 7 degrees above, then that's 7 times 69 miles. That's a lot of miles, where that's clearly not. They are actually appearing to intersect because that's where the convergence points meets, and that's where
Well-
it gets cut off.
Well, the difference between using miles or kilometers and degrees is degrees show you how something should look. Or even if you're taking a photo of it, you can actually say, okay, we can convert the units to degrees. You can't necessarily convert the units to kilometers unless you know what kind of lens you're using and a whole lot of other variables.
But each degree represents a unit of measurement, which can still be converted to miles. All it's really doing is it's just taking away from the fact that it represents such a huge number of miles by saying it's only 7 degrees or only 1 degree, whereas in fact that's still a huge number of miles of difference. It's just a way of obscuring it and downplaying the reality of how big and massive these distances really are.
Okay, so let's take. I'm going to try and use an example here to try and get you to understand why we use degrees instead of miles. You could have something that's just say 7 degrees, like the sun being above the horizon in the distance, or you could have something that's 7 degrees that's just a few meters. These would be the same angular size, yet there'd be different physical sizes. So using miles doesn't show you how it should look. If we use degrees, we can say, well, they should both look the same size. So you could have something a few.
Not adding up to me.
You could have something that's a few meters that's a lot closer than something that's 20,000 kilometers away. That's 1,000 kilometers above the horizon.
Right.
And that would be the same angular size above the horizon as a person that's, maybe I don't know how far away a 2-meter person would have to be to appear the same size, but I think it would be maybe 100 meters, maybe even closer.
Okay, so this is exactly where then distance and distance diminution comes into effect. If you're trying to apply that to actual size, then you have to take into account actual distance, which then becomes actual miles. And that's actually the last point I made, is where you're talking about the ships disappearing. It's the same sort of thing. You're claiming that a ship disappears over a curvature because of the distance, whereas in reality, because of convergence, there's a point where the water is going to converge to a certain distance where it creates the horizon. That's that horizontal to the eye line. So this is what the biggest problem. I don't know if I can draw this real quickly here. Most people don't get it. This is how, it's not going to work. That is how visual appearance works. Down here is your ground level. There's your viewing height. There's your horizontal eye line. What most people are doing is doing that. Is that they say, there's your viewing height. There's the flat ground. You are looking down to your visual convergence point, looking downwards. You are not. It's called the horizon because it's horizontal. It's horizontal to that top view there. That's your viewing point. That's your height above the ground, and the ground is ramping up to that point. The other point is ramping down. You just can't see it because you can see through the sky, but you cannot see through the ground. So the ground appearing to ramp up creates that point in the distance. And it's called the horizon because it is horizontal to your eyesight. It's not looking down at something in the distance and then thinking that getting higher on your ball is seeing further, because you're not. If you're going up on a ball, you're actually going further away from it.
Okay,
away from the center. Yeah.
Do parallel lines ever intersect?
They don't intersect, but one can obscure the other if one is physical and the other is see-through.
Okay,
The sky itself is see-through.
So
it's air.
How can they obscure one another if they don't intersect?
The ground obscures because it's physical. You can't see through it.
Yeah, but how can a parallel line obscure another parallel line if it never intersects?
because that's the nature of convergence. That's how the nature of convergence works, is because we see straight ahead. Whatever we're looking at is horizontal. That's the line of sight. Everything below us is going up, everything above us is going down. Just stand at a brick wall and have a look at it. As you change, move up and down looking at it, the line will always be at your eye level, straight line, and everything below you will always be going upwards. Everything above you will always be going downwards. That is the basic law of convergence and perspective. It doesn't change just because you're outside and there's no brick wall above you. The sky is still converging downwards. It's just that you will see much, much more of it because you can see through it, but you can't see through what's beneath you, which is the ground. That's why it creates the obscurity point at eye level. Hence why I'm continually having arguments with people all the time on Twitter, Facebook pages, that the horizon is always eye level. It is 100% eye level. It cannot be any other way.
So that still doesn't answer my question of how can a parallel line hide another line that's parallel to it if they don't intersect?
Because the nearer one creates the convergence point nearer than the one which you can see from much further. So as it gets further and further away, it obscures it. It doesn't intersect necessarily. It appears to intersect, but it's just obscuring it. It's still there. All you have to do is get higher up and you'll see more of it.
Okay, so I'm going to share my screen again because I've got this. I've got another 3D model to show you.
Sure.
And it's in Blender this time. So here we've got this 3D model that I've created, which basically it's got here, I think the observer height is 0.5 meter off the ground, and we can change it to be less. And when I zoom up on things that are far, like when you're back here, they appear like they're going to intersect, but when you zoom up, they don't actually intersect.
Right, yeah.
So this is a well-known thing. This is how things actually work.
Yeah, but
And
when you're seeing it from this perspective here, you're further back. That's a distance thing. It's always a distance thing. A distance and height.
So when I'm
Yeah.
actually not actually getting any closer, I'm just zooming up on it.
But that's the equivalent of getting closer.
Not really. Zooming up on
Yes,
something
really.
gives... No.
It is. Because otherwise, if you don't zoom in, then you're just using your normal eyesight. If you zoom in, you're magnifying the view.
Which is different to getting closer.
Sort of, yeah. Okay, I'll agree with you there. It's different.
Yeah, like especially when you look at the effect on the sides of things here. When you get back here, it looks very different to when you zoom up on it. These things aren't actually. If I actually go along here, jeez. If I actually go along and change
so what sort of point are you actually making here?
My point here is that things don't actually, these parallel lines here, they're all parallel. They don't actually intersect. So you can't actually have a parallel line here obscuring.
Yeah, but you've reached a finite point there, haven't you? If you continue that on into infinity, that either it reach a dot, or depending on your viewing height as opposed to the height of the objects, the bottom parts would begin to become obscured.
No, they wouldn't.
Yes,
you could continue this. You could continue this on forever, and you'd never see the bottom parts of the objects getting obscured.
That's because you're using then the point of view from the direct center between the top and bottom of those objects. If you got down lower, I don't know if you can do that in this program and actually take a point of view where you're much lower to the ground, you will find that the tops will start to become obscured eventually.
How low do you want to go? You can go 0.1 meters. You can go 0.05
Look, you can already
meters.
start to see curvature there.
No, you can't.
Curvature.
You can't see any curvature. The bottom of the objects is still fully visible. When you
Well,
zoom up on it, all the bottoms of the objects are fully visible here. They're not being
So-
obscured in any way.
yeah, but okay, so you're using computer graphics to do something to overcome the limits of actual human eyesight out in the real world. That's what you're really doing. I don't know how these programs work myself,
They use perspective.
but have you done a similar example out in the real world?
I mean, people
No,
have
of
done
course not.
different things out in the real world. It's very hard to say how something should look in the real world when there's a whole lot of effects, especially when you're going like a mile away, saying this is how a flat object would look in the real world. Mile away, or like 10 miles away, how something would look on a flat Earth in the real world is very, very difficult because the Earth isn't flat.
Okay, so you'll agree, for example, then if I went down to the coast and looked out at an object and it's above the horizon, over the water, that therefore it must be curved beyond that point, hence why it appears to be above the horizon. Is that your opinion?
What are you trying to say here? So you're
Say, for
saying
example,
if
like there's an
object is
island,
above the horizon, yeah.
like a fixed point in the distance where I can look out and the limits where my horizon appears, this island appears to be entirely above the water level. Would you say then that the ocean must be curving away beyond that point in
Well,
order
there's
to appear above the horizon?
Well, there's different amounts of curvature depending on your distance and depending on your viewer height.
How could it be different? It should be exactly the same everywhere for a spinning ball. The curvature should never be different. It's either there or it isn't there.
You've got so when it comes to it could be argued that no matter, like even over 5 meters, there's still some curvature there. It's just very small. When you've got something that's 5 miles away, you could say, okay, how much of the island should be hidden? And then, it could be, depending on your viewer height, it might be 2 meters of the island might be hidden, or it could be 30 meters of the island might be hidden, depending on your viewer height.
Okay, so let's say that 0 of it is hidden because you can see it just below the horizon. So therefore, from beyond that point, that's where the curvature must be beginning, right?
It doesn't really begin anywhere.
No, I know, because it's flat.
No, what I mean is if you've got
it doesn't begin anywhere because it
let me rephrase it. When you've got continuous
and level.
When you've got continuous curvature, if I have a point on a ball, or let's take my tinfoil hat. If I have a point on tinfoil hat, where does curvature away from this point here begin?
Everywhere.
Exactly. So when you've got a ball the size of the Earth, curvature begins anywhere. It just depends on whether you can see an island off in the distance. So you might be able to see the whole island off in the distance due to your viewer height. Doesn't mean that there's no curve in between you and the island. It just means that the curve might be small enough that you can't.
But I'm talking about beyond that island, because I can see that island above the horizon.
Yes.
And in your belief, in every glober's belief, that point of the horizon is where curvature is now obscuring everything beyond that point. Is that correct?
It will obscure things that are below the horizon, or would obstruct things that are below the horizon.
Yeah. So you're agreeing that that's the obstruction point where curvature should begin.
Yes, depending on your viewer height and the distance to the distance.
So if then you went to a different viewing height and had a look at the same island and saw it was surrounded by miles upon miles upon miles of flat and level water, where did that curvature go?
It didn't go anywhere. It's still there. You're just viewing it from a different angle.
Okay, so let's use another example now. Let's say we go to a baseball field. We see a pitcher's mound. It's got that curved bit above a flat surface. we can see that pitcher's mound. Do you agree that we can see the pitcher's mound from ground level?
Yeah.
Yeah. So let's say I went up to the top tier of the highest lookout point over this baseball field. Should I then therefore see this pitcher's mound appear to be flat?
Probably, I think.
No.
I'm not too familiar with
You
baseball.
cannot. Yeah,
I'm not
me
too
either.
familiar with baseball.
I'm just using that as an example because the pitcher's mound is an example of actual curvature above
Okay.
flat surface. But when we're talking about the ocean, when we think we see something that's curvature, and yet it disappears when we get higher up,
Okay,
you
so
should
now
still be able to see it, just like you can see a pitcher's mound. You can still see the pitcher's mound from above. You can see shadows on it. You can see the shade of light, but you cannot see that on the ocean ever.
Okay, so
no matter how high you go.
So the difference between the ocean and the pitcher's mound is the pitcher's mound. If you look at it from a stand, the pitcher's mound is very. You'd be a lot further away from the pitcher's mound than you would be by going up into even an airplane. Like if you're in an airplane, you might be able to see a small amount of curvature if you don't have any. And I've seen videos of this where they saw a small amount of curvature because they didn't have any clouds obstructing their view. And whereas a pitcher's mound, you'd be able to see the whole thing from a far enough distance.
Yeah, but a pitcher's mound is an example of real and actual curvature, just as a mountain is, just as a mound is, any sort of hill, something that isn't flat. The curvature of it does not disappear just because you got higher. Now,
well, it's not
simple example of seeing an island on the horizon, completely above the horizon, where people mistake that convergence point as the place where curvature begins, and yet when you change your perspective and look at it from a higher point of view and see that there is zero curvature, it is surrounded by flat and level water the whole way for multiple more miles, simply proves that it's just an incoherent thought to assume it's curvature in the beginning place. Water does not curve. It seeks and finds its level and fills its container. So all of the physical parts of Earth must be above ocean level.
I have a question for you. Does water always stay level all the time?
It seeks and finds its level.
So what about during tides? What about during
tides? Are just being pushed around by the effects of the same force that holds the moon up in the upper parts of the atmosphere. It's a repellent force, and it pushes the salt water around, and hence why we have 2 tides per day, which is absolutely impossible on your globe model for the mass of one moon to pull 2 tides around per day.
So how is the tides being caused in that? Like you're saying
it's
that
it's a repellent force. It's a repellent force, a bit like
what repellent force?
Diamagnetic force. Like when you push 2 pole magnets.
Are you there?
Force is keeping the moon aloft. I'm not saying I know exactly what it is, but whatever that force is, it's electromagnetic, and it is pushing the oceans ahead of the moon. And then when the moon reaches the edge of the continent, the moon keeps on going, but then the water seeks to rebalance itself, hence why that flow-on effect will create a second high tide on the other side, by which time the moon comes back around again and starts pushing it forward again. So you can get 2 moons on a flat Earth, 2 tides, no problem at all. But you cannot have it on a globe.
Okay. So do you have any evidence at all that magnetism can affect water?
Yeah, there's quite a bit. I don't personally have it at hand at the moment.
I'd love to see some because I have seen someone try actually using salt water. They've put a whole lot of salt into some water to try and see if they could affect it with a magnet. And they tried to affect it with a magnet. They could not affect any of it with a magnet.
Yeah, well, you know that salt water is made up of pretty much all the minerals that exist on Earth, including all the heavy metals that exist. So, were they just using sodium chloride, or were they using everything on top of sodium chloride?
Well, the problem here is that you haven't got any evidence to demonstrate that that magnetism can affect water or even salt water.
I'll agree with that, but what I have got is my own personal experiences of seeing the highest tide approaching in front of me, washing up on the beach as the moon is approaching from the east. And that
Yes,
makes
but
no sense on the globe Earth when the moon should be pulling the water away. That should be on the lowest tide as it's pulling it, and then as it heads over, it's pulling it back again. But no, it's actually pushing it in advance.
So personal experience doesn't matter. Otherwise, I could say I have
Why?
personal experience that the Earth is a globe, therefore debate over. Personal experience doesn't really mean much in the realm of science.
But you're just calling me a liar then if you say that, because I'm telling you that you are, because I am talking about a real and actual thing. I'm not just saying, oh, I saw the curve or I saw the flat. All I'm saying is the tide was approaching in advance of the moon also approaching. And that's a real, tangible thing that I have personally witnessed multiple times. But on one specific time when I really looked for it, I thought, this is really weird. The water's creeping up over the dry sand, and yet the moon is over in front of me coming towards me. It didn't make any sense according to a globe model.
It does make sense though. You would expect the the tide to start rising before the moon gets there, because it's not as though the moon arrives and suddenly you've got high tide.
You're putting the cart before the horse here. Okay, the cart is being pulled by the horse. In your opinion, the tide is being pulled by the moon. You can't put the tide ahead of the moon.
Wait, was it high tide? Like, did you have the peak of high tide before the moon got there?
Yeah, well and truly peaking, like well and truly above the dry sand.
I'd need to see data on that.
Yeah, no, I didn't record. I didn't have a camera at the time, but it kind of freaked me out in that how high is this water getting, pushing the debris and stuff up across the dry sand while the moon is in front of me in the middle of the afternoon sort of thing one time. It was weird.
Yeah, I'd need to see data on that to just verify what's going on there, and then
absolutely, and it's something that should be researched. Definitely, it's the same with the lunar eclipse. The time when I watched the full-on lunar eclipse back in the day when I was a full-on globe believer, believed in the heliocentric model 100%. Here I am going to watch a lunar eclipse. So I'm watching the moon coming up. It's about 9:30 in the evening. So the sun had been set for about 3 hours. 2.5 to 3 hours, and so obviously the Earth should be right in the middle of it. We should see the shadow either coming up from the bottom, or maybe because of the timing coming from a different direction. But no, all of a sudden this weird shadow comes from the top left across the moon. It made zero sense to me whatsoever, and it really shocked me to the core because I thought I understood all this stuff about the heliocentric model. It just was completely and utterly wrong. There was nothing that made any logical sense whatsoever about it.
So the thing with when it comes to lunar eclipses is you've got two different bodies moving. You do realize that you've got the Earth moving, and then you've got the sun is moving. But the main thing to consider is you've got the Earth. You've got Earth rotating. You've got Earth moving. You've got the and you've got the moon moving as well. So it's not necessarily going to appear exactly in the way that you'd expect it to appear if you were only accounting for one body moving.
Yeah. I understand that. Like the Earth the moon is actually going backwards around us. So, you have to take that into account. So as the Earth is rotating towards the direction where the moon rises, away from where the sun had already, to create this perfect alignment.
The internet is dying fast.
Several other lunar eclipses which do not add up whatsoever. And the other thing that's really gets me is that if you try to create a shadow across a spherical object, you can't do it with another sphere.
What's that?
I thought I heard somebody.
Yeah, I thought I heard. Okay. Yeah.
Yeah, if you're trying to make a shadow across a spherical object, you cannot do it with another sphere. If you use
Yes, you can.
if you use an actual flat sheet of cardboard and do that across a sphere, it will make what appears to be the thing that we see in a lunar eclipse anyway. But I do not believe for 1 second that it is the shadow of the Earth causing the lunar eclipse. There is another object up in the sky that comes between the sun and the moon, and that is what blocks the sunlight from reaching the moon, and that's the lunar eclipse explained.
So what evidence do you have for this other object?
Plenty, absolutely plenty. I've got personal pictures I've taken myself. I've been collecting pictures for ages. It's known as by two different names. Traditionally in the English language, it's known as Lilith, which is also the dark moon, or sometimes dark sun even. It's just like a secondary moon that didn't make it into orbit around the Earth the way our moon does. It's hanging too close to the sun the whole time. And that's why, just like a new moon, it isn't visible to us, but every now and then at sunset, it becomes visible, and it looks more or less like another sun because it's setting at the same time.
So do you have any photos or evidence or anything to support that claim?
Yeah.
Can I take a look?
Yeah, I don't know how I can bring them to this discussion.
Because I mean, I hear this claim a lot, but nobody can ever provide any evidence. So you've actually seen some kind of dark thing blocking out stars or something? Is that the evidence?
No, I've actually taken like a few pictures of the sun rising, and then upon looking at them closely afterwards, taking the picture, I can see another object in the sky which is partially hidden behind clouds, so it just can't be dismissed as a solar flare on the lens. And at the same time, I've seen multiple other pictures that other people have taken that looks like two suns.
Oh, so you're talking about two suns, not anything obscuring the moon during
It appears to be two suns because, I mean, the moon itself appears pretty much like the sun.
Okay.
In size, and if it's right next to the sun, well, yeah, it doesn't work that way.
How small is this other object? Is it a lot smaller than the sun when just looking at it? Because I've seen things where it's where there's what appears to be a smaller object near the sun, and it's probably something like Venus or something like that. I mean, there's also times when
the pictures I personally took, it appears to be quite small. It's what I would consider.
So yeah, like
sixth of the size of the sun.
So there's times when I've taken, not taken, but there's times when there's been things like the moon, not the moon, just hold up. When there's been things like Venus making a transit across the sun, but that I don't think that is what you're talking about. I think it's something that would be a lot bigger.
Yeah, this would appear much, much bigger than Venus. Venus is like a large star to our visual observation. This thing on the images that I was able to get, I can't bring them up, so I don't know how to do it.
Okay. Do you think you'd be able to screen share some of the images or no?
Let me see. How do you screen share?
Oh, there should be a button at the bottom, a green button that says screen share.
Yeah.
That should allow you to.
Is that bring it up?
Yep.
Yeah, so if you look where the pine tree is on your left, and you look just above it to the left, you'll see the small orb object with a little bit of cloud in front of it.
So I'm having trouble seeing it. I think I might be able to see it, but
yeah, it's just
is it where your mouse is?
Where my mouse is now.
Okay, yeah, that doesn't look like it would be anything that could could be something like a small cloud, or it could be anything.
Correct, correct. I agree, and that's why I was quite weirded out by it.
That's the thing. It could be anything. It does to claim that that is what's been blocking out the. To claim that's blocking out the moon during a lunar eclipse that's a huge leap.
It is, but you have to take it all into perspective.
So you're a fan of Fight the Flat Earth and Team Skeptic.
I love them. Yeah, they're great. But here's another compilation of images, which sort of shows a second sun as well, which is what we are suggesting is either this Lilith or Rahu, as some people call it. And when you take it all into perspective and the height of everything, then it could well be that object which is obscuring sunlight in the moon and creating the lunar eclipse. And therefore, the only light that reaches the moon at that time is Earth reflection. And because our atmosphere absorbs all the blue light spectrum,
One of the problems here is that when it comes to this other object, the only time we see it is being very close to the sun, right? And
well, you can't see it because it's too close to the sun. That's the whole point. It's the whole reason why you can't see the new moon is because when it's too close to the sun is too bright, and by the time the sun sets, so has this object. So you can't normally see it.
So when it comes to this, I'm trying to work it out because it appears that when this object is close to the sun, that's when it appears. Am I incorrect?
It doesn't appear. It comes between the sun and the moon.
No, but right here, it's...
Oh, yeah, right.
Yeah, right here, it's close to the sun, and when it's close to the sun, it's visible. Am I getting that correct?
It's always close to the sun. It's just that on occasion, atmospheric conditions are good enough so that the atmosphere is blocking enough of the sunlight that this object appears. That's my take on it. I mean,
do you have any?
I know as much about it as most anybody else, but I'm trying to gather evidence, and this is one of the images that I've been able to get that shows multiple examples of what appears to be what we call a second sun or second luminary in the sky, which is only visible in certain atmospheric conditions.
So there's plenty of evidence that this can be explained by refraction. It's a very rare refractive effect, and I've read about it a few times. Although it's very hard to find a lot of information. I think that it's a real stretch to use that particular image as evidence that this is an actual object, especially seeing as it's just a small point in that image that you're claiming is this other object, when in the other images you presented it's a lot larger.
Yeah, well, it appears that way. Like in this one here, if you can still see it, the sun itself is actually a tiny little dot somewhere down here, but because it's so foggy, it's like really foggy down in a valley. And this thing was not visible to the naked eye whatsoever. I only saw it in images afterwards, but they were pretty cool pictures. And it was about 2 weeks after this that way over to the left over here, almost behind me, directly opposite this sun, for a full moon setting where something was like appearing to be taking a tiny bite out of the top right-hand corner of it. So by the time this thing had spun around to come between the sun and the moon 2 weeks later, that would be enough to cause that partial lunar eclipse. That makes sense. Like if it was the Earth doing it, why wouldn't the entire Earth just completely block it out? But,
well, was a partial lunar eclipse scheduled for that time? Do you know?
Yeah, absolutely.
So if a partial lunar eclipse was scheduled for that time, it's fully explainable that there'd be only a small bite, or what looks like a small bite taken out of the moon, because sometimes the moon doesn't sometimes the Earth doesn't pass directly in front of the moon and the sun, or directly between the moon and the sun. Sometimes it will pass.
Yeah, but it was roughly this same time of day where the sun was coming up behind me and the moon was still visible setting. So it's again what they call the selenelium, where both the sun and moon are visible at the same time and you've still got a lunar eclipse, which is completely impossible because...
But it was only a partial lunar eclipse, right?
Yeah, but the partial part was at the top right-hand corner, or quadrant, for want of a better word, of the moon. It wasn't coming from below, where you would expect, because there's nothing in between. The Earth is obviously beneath both the sun and moon.
Well, do you have? Did you have any? Did you take any images?
I did get some of that, but yeah, I was having a lot of problems with the new phone at that time. But I managed to put some onto my Facebook of the actual images of the lunar eclipse. Yeah, this is heading to work in the morning, so I don't have a lot of time to stop and pull over and just take the photographs. Do what I can when I can.
Because a lot of these claims that I hear from flat earthers, sometimes like I've heard someone say that I think it was at midnight or something, the Earth or the Moon was at its zenith high in the sky, and it was on the same day that there was a solar eclipse. Yet they didn't have any evidence for this whatsoever. No images. And
what was that? They said the Moon was at its
zenith during on the day of a solar eclipse, like at midnight, it was at its zenith or something, and it was very strange that they didn't have any images, because you'd think that an image like that would be amazing.
I have to admit that, from my experience, a lot of flat earthers have very little experience with the Moon, have a clue about what it does and how we see it and how the phases all work. So when it comes to the Moon itself, I wouldn't listen to most flat earthers. You can listen to me, because that's one thing that I have specialised in, and I know what I'm talking about. I know how the phases work.
You've got some very weird beliefs about the Moon. Like, I know that you think that it was dug out of the Grand Canyon, don't you?
I've made some hypotheses about how I think it might have come into being, but that's got nothing to do with my understanding of how the phases work and how we visualise them, and how the Moon is 100% lit by the sun. Anybody who tells you otherwise they don't know what they're talking about. And they say the Moon is self-illuminating. I think, okay, there's a flat earth troll. They don't know what they're talking about.
I mean, I have gotten some images of the Moon when it was lit by... I had an image of a moon and a bull, a concrete bull. And in both images, you could see that they were illuminated in this exact same direction. And
exactly, yep. I agree 100% with that. I've done the same thing myself plenty of times. And I agree that the phases perfectly match up with what you'd expect to see, because the Moon is illuminated by the sun. There's no doubting it.
But this is what you'd expect to see you'd only really expect to see this if the sun and moon were both very far away.
Yeah. Yeah, but even so, even though they are both far enough away, the way that sunlight illuminates both us and the moon gives almost the exact identical pattern. It might be slightly different by a tiny bit, because the moon is much higher. But apart from that, the moon is illuminated by the sun.
Okay. I do want to... There's a few things that you claimed that I do want to get into. So one of the things that you claimed is that if the Earth was a globe, it would only be blocking a small portion of light from the sun.
Yeah.
You claimed that in your opening statement. I want to respond to that, because I don't think you quite know how it works. So let me try and iterate your point, see if I'm getting it correct. So you think that if the Earth was a globe, this light coming out of the sun would illuminate the night sky, and you would have, and the Earth would only block a small portion out of that, so the rest of the sky would be illuminated by the sun. Is that what you think?
Yeah, that's sort of what I'm suggesting.
Why do you think that?
Unless you agree with the same philosophy that says that daylight is only caused by the illumination of the noble gases. Yes.
Why would the night sky be illuminated by the sun at all? It makes no
Because
sense.
sunlight is all permeating. It's 93 million miles away. It should be permeating everything except the part where Earth is in shadow from it. But just because the Earth itself is in shadow doesn't mean the rest of the universe.
Well,
The visual
it
universe.
makes no sense to assume that that the sun would illuminate the night sky, though, because that light wouldn't reflect off anything for the Earth for it to be seen by people on Earth.
Okay, so you're saying it does reflect off something to create daylight.
No, we get the sun.
Daylight.
We get the light directly from the sun during the day. During the night, we don't get any sun because it doesn't reflect. You'd have to say that the light from the sun would reach someone on Earth during the night. You'd have to have some kind of object reflecting light from where the sunlight reaches.
Okay, so in your opinion, then what is twilight?
Twilight.
Yeah.
That's evening, isn't it?
Yeah.
Yeah. So there is a bit of atmospheric or Rayleigh scattering that does scatter some of the light, but it's not a whole lot. That's why you don't have a whole lot of light in midnight.
Yeah, so in other words, it's the atmosphere still being electrostimulated by the presence of the sun as it gets further and further away, creating the faint glow of the fading neon gases that create these colours that we see both at either dawn, twilight happens at dawn, or dusk. Just simply because it's not in the immediate visual presence of the sun. And as soon as it becomes in the immediate visual presence, the sun becomes a blinding bright light, very hard to look at.
Wait, how far away? Do you have any sort of idea of how far away the sun can illuminate from, or is it? Do you not have those numbers?
Basically, just between line of sight. It's still according to the laws of convergence and perspective. If you've got a line of sight of the sun, it will illuminate, and once it goes beyond that line of sight, you've got visible objects, usually mountains or something, obscuring it. It stops illuminating your local atmosphere and it gets darker and darker. Like in some places, if you're right near a mountain, it goes dark really quickly. If you're somewhere like on a west coast where the sun can linger for many hours, you have a very long, drawn-out twilight.
So, in New Zealand, the during the summer, especially when you go the further south you got a lot of hours of daylight. And do you think that the sun is circling around the North Pole?
I think it's circling around the equator.
One sec. I will give you a chance to respond if you had more to say, Flat Earth Aussie, but I did want to mention that we'll probably go into Q&A as we've gone over the discussion time. It's just
That's all good, mate. I'm having a bit of trouble.
my mic cord unplugged. So
Okay.
we will jump into the Q&A in just a few minutes. If you guys, I hate to cut it short, but we'd be more than happy to have you guys back on for a round 2 if you guys would enjoy it. But just because I have to keep a promise. So if it's okay with you guys, if we have maybe a few more minutes and then go into the Q&A, we'll start reading super chats. Thanks, Dennis D, for that reminder.
No worries, James. Yeah, do what you got to do, mate. It's all good.
Yeah. So I'll just sort of try and round off the question that I was asking. So the question that I was what I was saying is in New Zealand, you get, especially further down south, you get a lot of hours of sunlight, and the sun would have to be very, very far away. In fact, you'd actually probably be closer somewhere on the equator to the sun than you would be in New Zealand. Yet New Zealand gets more hours of sunlight. How does that work?
Well, that is part of the mystery of the sun, which I'm still trying to address and show proper visual explanations for how that actually works. But basically, the nearer the sun is, the more it is going to illuminate for longer. And when we're in summer in the outside part of the equator, the sun is actually nearer, even though it's still taking the exact same path. It is still illuminating far more of the noble gases. And by being nearer, we can see it for further. Therefore, we have longer daylight hours as it's nearer. For the people in the north, however, it's nearer to us in appearance. So therefore, for them, it appears to be so far south that they actually have shorter days, and therefore they're winter. So it is a tricky part of perspective. It's a very 3D physical thing.
I might have to work this out because I'm pretty sure I could work it out and show that you wouldn't get any longer. You should actually get longer daylight during the equator, which is not what we see. We see longer daylight when you go closer south in the summer for the southern hemisphere. So
yeah, that's what I'm saying. It is longer while it's closer to the southern hemisphere.
But you should actually see it. You should also have longer daylight in the northern hemisphere because it would be closer for people in the northern hemisphere.
It's not that it's further from them because it's lower down. Like, I don't know if you can visualize a tunnel, up and down tunnel. So when the lower part of the tunnel is nearest to you, it's going to appear to make a bigger circle. But as it gets higher and higher, it will appear to make a smaller circle. That's basically the path of the sun as it goes around the equator the whole time. So as it's actually nearer, it appears closer to the outer part, but not to the inner part. The inner part is further away.
I could probably actually use some mathematics to show that it would be actually closer the further north you go.
But you have to take into account, again, this, as I call a firmament, the upper helium and hydrogen atmosphere, which is still quite close to the actual Earth. That's where the apparition of the sun is.
You'd still be closer the further north you go, though.
No, it wouldn't.
Yes, you would.
Because, say, for example, you're laying on your back and something's spinning around above your belly. As it came closer to you,
I could probably actually use mathematics to show that it would be closer to the North Pole than it would be to New Zealand.
No, but as it gets closer, it appears to take a bigger circle, is what I'm saying.
Yeah, but I'd still be able to use mathematics to show that it should be closer to the North Pole. But I think James wanted to get to...
Yeah, I'm quite
and we're going around in circles right now.
We would be definitely thrilled to have you guys back on, as people really enjoyed this. There are already over 100 likes and still over 300 people watching. So people have really enjoyed listening to you guys. It's been a total blast. So I want to remind people, both of these gentlemen, I put their links in the description. So if you're listening and you're like, well, I've got good news. Go down there in the description box. Click those links to hear more. So with that, we're going to start out with the Super Chats. First, we'll get through as much as we can. Thanks so much, folks. Dennis D, thanks for your Super Chat, who says, Flat Earth Aussie looks like an old chess master that can cast spells. Very nice. Steven Steen, thanks for your Super Chat. He says, I dislike everyone in the chat. Go away. He's our friendly, benevolent dad joke troll. Thanks, Steven Steen, for your other Super Chat, who says, James will read anything, guys. Just Super Chat it. Oh, that's kind of true. Steven Steen, thanks for your other Super Chat, who says, I am Ron Burgundy. Thanks for that. Tioga, thanks for your Super Chat. She says, Steen is just the little ghost in the modern-day debate machine. So true. We love him. He's a funny little guy. Dennis D, thanks for your Super Chat. He says, it's not Flat Earth Aussie's fault because he clearly grew up back when everyone thought the Earth was flat. It's a generation thing, that's all. Oh, very good. Oh, my goodness.
Yeah, that's pretty poor because I grew up being the biggest globe head you could imagine. I used to tell my friends, oh, you're not having a birthday. You're just celebrating how many trips around the sun you've had. So, come on.
I've heard that one before.
I like it. Next up, we have Schrodinger's cat, who says, Flat Earth Aussie, what are noble gases?
Yeah, that is particular gases that illuminate in the presence of an electrostimulating force. It's basic.
Gotcha.
Neon, argon, krypton, all that. There's about 5 of them.
Thanks so much. Next up, appreciate your super chat from Dennis D, who says, Flat Earth Aussie, I'd worship your mythical beard and hair. Very nice. Stupid Horror Energy is in the house. Thanks for your super chat. She says, Jesus wept. I don't know why she's quoting the Gospel of John, but thank you very much. Dennis D, thanks for your super chat. Says, Flat Earth Aussie is charming, but too bad he's a flurf.
Oh,
He's heard that one before. Okay, next one.
that hurt my feelings. It got better.
Roxana, thanks for your super chat, who says, question for Flat Earth Aussie, have you ever seen Polaris from Australia?
Nope.
Gotcha. Thanks very much. Brad Dubai, or Dubay, forgive me if I mispronounce it, correct me. They say big numbers scare flurfs.
Oh, what a load of crap. We bring the big numbers all the time and tell you what your beliefs are. Some ridiculously supersonic, hypersonic speeds. And because we grasp reality and understand how impossible they are, we understand the big numbers. You guys just hand wave them away and say, yeah, it's all RPM relative. You don't grasp them at all.
Oh my goodness. Well, thank you very much. Next up, Philip, thanks for your super chat. Says, I think they're saying this is, Flat Earth Aussie. They say, how do you explain the fact that we always see the sun crossing time zones in the same order, not looping back like the Flat Earth model says?
No, it doesn't. The Flat Earth model is like a 24-hour clock face. And wherever the sun is directly above, you get a local 12 p.m., the opposite side being 12 a.m. It's where's your looping back? Your time zones work out perfectly.
Gotcha. Thank you very much. Next up, appreciate your super chat from Stupid or Energy strikes again. She says, why doesn't the sun change in angular size? Nasty woman. Very nasty. But yes, why doesn't the sun change in angular size?
That's pretty simple. It's already so sufficiently far enough away that by the time we see it in our local environment, where our obscurity points are only about 3 or 4 miles away on either side, the distance that it's actually gone is irrelevant to the distance it already is. Just the same as looking at, say, a distant ship on the horizon, going from as far south or whatever north as you can see. It won't change in angular size either because it's already so far away that the actual distance it covers is irrelevant to the distance it already is.
Gotcha. Thank you very much. We got to find one here for Planner Walk. I'm finding it. Don't worry,
Okay.
Planner. I'm looking for it. Stringer News 1. I mean, this could be for you. They say, kids, remember, this is a lesson to never do drugs.
Let the drugs do you, mate.
So sorry, Flat Earth Aussie. Okay, next up, Steven Steve, thanks for your super chat, who says, when is Kyle C on Modern Day Debate again? Very funny, though he's technically right. We did have, this is like years ago, we had Kyle Curtis on. That was before the dark times, before the Empire. Planner Walk 94, Ranger Man 9404 has a question for you, Planner Walk. This is perfect. Okay, so They say, Planner Walk, do you really expect a flurf to answer a question?
I mean, it depends what the question is. Like when you try and ask them questions about the globe or about certain things, they might give you a somewhat tangentially related answer. But if you ask some questions, like if I ask Flat Earth Aussie Jesus, do you like Star Wars? But I was asking Flat Earth.
Me?
I thought that was hypothetical.
What was that?
I thought that was hypothetical.
But do you like Star Wars?
Do I like it?
Yeah.
Which one?
I mean, we'll go with the original trilogy.
Nah, didn't like it.
Okay.
Gotcha. Thank you so much. We appreciate it. Next up, Brad Dubay, thanks for your super chat, who says, perspective does not change reality. It's a good
No,
one-liner.
but it is how you view reality. You have to use the perspective you're given with to view it. If you don't like it, so what? It doesn't change it. It is what it is.
Gotcha. Thank you. Next up, appreciate it, from Sleepy Dan, who says, Flat Earth Aussie, if the sun is as close as you say, why don't you get hotter when you approach it? Temperature drops with elevation. Look at snow on the mountaintops.
Yeah, that's a good question, because the nature of light is that light itself doesn't create the heat, but the closer it gets to warming of the thermal mass of the Earth, that's where you get the heat from. It's a bit like on a really hot summer's day, you could hold your foot just above a hot footpath, and you don't feel the heat until your foot actually touches it, and then it makes you jump 10 feet in the air. The heat comes directly from the source and not from the sun itself. So getting closer towards the sun means you're further and further away from the thermal mass, and because air has less and less mass as you get higher up, it's just going to get colder and colder. You need to be near to something that actually heats up and holds that heat.
Thank you very much. Next up, Stupid Horror Energy strikes again. She says, James gets hotter as I approach him. Why doesn't the sun? You wish. Okay, next up. So I think that was basically the same question as the last one regarding the sun. Christopher Hoogan, thanks for your super chat, asked, what keeps the moon up there if it's in our atmosphere?
Well, that's the mystery, isn't it? I tend to think it's some sort of diamagnetic force that repulses against the saltwater oceans, and that same force is what pushes the tides around. What it is, I don't really know, but I can see how it works, and so it's something that we need to work on. So, yeah, that's something we need to work on.
Thanks so much. Next up, Sigifredo Sarabia is in the house. I always get excited. Sigifredo has been hanging around here at the channel a long time. I don't know if I ever told this story when I met Samuel Nassan, one of the debaters. I went to Malaysia, and like one of the first things he was like, "Who's Sigifredo Sarabia?" And I was like, "I don't know," but he is asking this: why doesn't the phone work higher and closer to satellites? So I think they mean like if you're maybe on a mountain or on the airplane, whatever.
Yeah.
Well, so the reason why is because cell phones just communicate with cell towers, which then communicate with satellites. But there are some phones there are some phones that will only communicate with satellites. There's one person who mentioned that, I think it was Landon Knoll, who has been to Antarctica and had to use one that would communicate with satellites.
Gotcha.
And he only got like a few minutes signal.
As far as I'm concerned, what they call satellite is simply just radio signal, and there is a little bit of delay over very vast distances with the radio signal. You're not sending it into outer space where everything is spinning at zillions of miles an hour.
Gotcha.
That would not work.
It's far more complex than what I mentioned, but
Thanks very much, and appreciate that. Yeah, so stick that in your pipe and smoke it, says Fredo. Okay, next up, Dennis D, thanks for your super chat. They said, in a spring tide, there can be a high tide on both sides of Earth. It's complex on why there would be high tide on the opposite side of the Earth.
Yeah, there's absolutely no reason why the gravitational pull of one moon with one mass would create a secondary high tide on the opposite side, because we know, for example, that if we believe the heliocentric model, the Earth is pulling all the oceans towards the center, and then the moon is acting against the Earth's gravity to pull a tide to one side. So there's no reason why then the opposite side of the Earth from the moon would allow a secondary higher tide. It's just physically impossible. All the gravity would be pulling towards the moon with the Earth. So, yeah, that in itself completely debunks the globe Earth.
well, I think that it's a lot more complex than the moon. exerting a gravitational pull on the water, because if that was only what happened, then you'd be correct. But there's a lot more to that, which involves the way that gravity works, and it actually involves water pushing on water, and actually involves the Earth's gravity as well.
Gotcha. Thanks for that. Appreciate it. Next up, we have a super chat from Graham Bouvier. I hope I pronounced that name right. So I'm pretty sure like Bouvier, I think that was like Marge Simpson's maiden name. But thank you, Graham, for that super chat. Let me know if there was a comment you wanted me to attach to it. Stringer News 1, thanks for your super chat, said, show Planner Walk some love. That's nice. You have a fan out there. Red.
That's always good.
That's a very sentimental. Red Cosmos Devil, thanks for your super chat, who said, have you guys watched Gods of Egypt? They depict flat Earth and not spherical. LOL.
Haven't seen
I
that.
have not seen Gods of Egypt.
Very embarrassing. Me neither, though. Okay, next up, appreciate Stupid Horror Energy. There she goes again. She says, I went to Malaysia and I met James on the Incan pyramids, and he said he saw a bridge curve over the waters. How do you like them apples? Very funny. She's quite the troll herself. Next up, thanks for your
Anti-refraction.
I appreciate your question. King Crew, jumping into the standard questions. King Crew asks, we already have a question for Flat Earth Aussie. Has he ever had 12 hours of sunlight in Australia? It comes from Brixhamite. Is that like one of your long lost sons or something, or?
Beats the hell out of me. I've come across King Crew quite a bit before, and he seems like a reasonable sort of fellow, but yeah, God knows what he's talking about.
Gotcha. So why I don't? So you okay? You guys are actually like buddies. It sounds like. What about? Have you seen 12 hours of sunlight in Australia?
We can have up to 15 hours sunlight in summertime.
Huh.
I mean, I have.
Once we pass the equinox, we're back to 12 hours, and now we're going backwards again until our next solstice in the middle of June, or end of June, where the days get shorter and shorter.
Planner Walk, you look skeptical. Are you skeptical?
Well, I was just going to say, I haven't seen 12 hours of sunlight in Australia, but I have seen more than 12 hours of sunlight in New Zealand.
Oh.
Yeah, and we're pretty much on the same sort of sunlight scale of things.
Yeah.
Really interesting. But I want to know who Brixhamite is. Why would they mention it without... Josh Paley, thanks for your question. They asked, Flat Earth Aussie, you argue that your senses say the Earth is flat. Mine say it's a globe. Why is your experience more valid than mine?
Probably because I'm not a fruit bat. I've never hung upside down in my life. I've always been upright. And according to all the laws of physics, observable levels, water level, perpendicular, parallel, all that sort of stuff, tells me that I'm on top of the world and I'm not hanging upside down. And so if you think you're on the other side of the globe hanging upside down, maybe you're a fruit bat.
That is super interesting. Thank you for that. And Top Dog Shattuck, who has asked many questions tonight, asks, could both sides repeat what the other person's view is to see how much both sides understand each other? What do you think? Well, I think that's a great idea, Top Dog Shattuck. Would you guys be willing to, maybe like in 30 seconds, we'll give you the challenge of even not only representing your opponent's view, but like shrinking it down into like 30 seconds, the best case you could lay out on behalf of your opponent?
Yeah, sure. I believe I'm in curved water and think I live upside down on a curving water ball speaking to a vacuum of space. It's impossible because we have a pressurized atmosphere.
How is that?
But I believe it. I believe it.
How is that the strongest? Okay. I mean, Flatterwalk, if you want to do the same, we can't blame you.
I don't know. You've got to be insane to believe in the globe these days.
It's a lot more complex than Flat Earth Aussie Jesus put it.
That's very funny. I tried, Top Dog Shattuck. I tried.
Like-
Thanks.
I could try and
It's a lot more complex.
summarize
No, it's
Flat
not
Earth Aussie
simple.
Jesus'
Flat.
argument.
Appreciate that. Thank you. We have one last question from Flash Gordon. Thanks for your question. They asked, for Flat Earth Aussie, have you ever been to the edge of the Earth?
Yeah, I go there every night with the dog.
Okay,
Quite
he's now he's just trolling us. Okay.
No, I get a really good view of the stars. I can show you pictures and everything. I go to the edge all the time.
Thank you very much. Let's see. Wait, hold on a second. I feel like my internet is going in and out. Let me. I can't load up the any of the most recent questions. I think stupid Horror Energy strikes one more time tonight. She says, in Malaysia, James was dressed in a tuxedo. He had a... Oh my gosh. I'm not going to read that. Okay. He had something going on that made me blush, but he was quite the gentleman, to be continued. Nasty, nasty lady. Brad Wagner, thanks for your super chat as well. If you have a comment you want me to attach to it, let me know. Really appreciate it. And let's see.
I thought you did.
Oh, did I miss it from Brad Wagner?
Yeah, it says, Planet Walk, are you drinking Kool-Aid? Good job tonight. And I can respond to that. No, it's not Kool-Aid. It's just some water with flavoring.
You've got cordial.
Yeah, pretty
Is it
much.
Cotties? Cotties?
What? It's
Cotton.
I don't know if I have the. No, I don't have the packet. Basically, it's an electrolyte thing.
Well, I've been drinking coffee all this time.
That's awesome. And it's for everybody who doesn't know,
Directly from my homebrew bottle.
very nice. Both of our guests, they are actually, are you guys in the exact same time zone or just an hour off?
No, I think it's like
It's
2
3
hours
hours,
over.
Okay. So
I
both
used to go out with a married woman.
Oh, where did that come from?
Well, we used to talk all the time, so I knew that it's 3 hours.
Oh, okay. But yes, so both of our guests, they are in the future. If you're watching from the U.S. or from Europe, right now it's Friday. It's Friday and it's 9 p.m. where I'm in Mountain Time, and both of our guests, they're already into Saturday, and we are so honored to have you guys spend some of your Saturday with us. So I'm being serious. I know I sound facetious, but I'm being serious.
Oh, we're on house lockdown, so I had nothing better to do.
Well, thanks. That makes me feel great. Next up, let's see. We have one more, and we have a couple more. Dennis D, thanks for your question. They said, Flat Earth Aussie, don't be offended that I was joking about your age. You got good vibes, even if you are a flat earther. Another backhanded compliment.
Oh, thanks, mate.
Really nice. Let's see. Oh, okay, yeah, you're right. Brad Wagner did ask if you were drinking Kool-Aid, Planner Rock. You're right, and said, good job tonight. Thanks for that. I'm like a little bit behind yet. Let's see. Dennis
Okay.
D, thanks for your super chat, Dennis D, who said, both opponents are very mature and respectful. Very nice. I have to say, you guys really are like a pleasure to have. You guys are very respectful, and I honestly, people have really enjoyed this, so we really enjoyed it. We'd love to have you back anytime. Want to remind you folks, both of their links I put in the description, so go ahead and you can check out more content from these gentlemen. And with that, I want to say, guys, thanks so much for being here. If you have any last goodbyes.
Yeah, look,
Well,
yeah, mate.
Well, I did want to summarize Flat Earth Aussie Jesus' argument in 30 seconds, which I didn't get to do.
You bet.
So yeah, his argument is that the sun illuminates half of the Earth using the noble gases that are higher up in the atmosphere, and we can trust our eyes because if we can't trust our senses, what else can we trust? And it's all due to density and buoyancy why the noble gases are higher up in the atmosphere, and the sun is just a bit higher than that, and it's a Tesla coil effect.
Gotcha. Thanks so
Think
much.
Yeah,
Next,
pretty good.
we had just 2 last super chats fly in. Ryan Wallace, thanks so much for your super chat. I'm wondering, like Ryan, I think I think I've seen maybe you've done a super chat before, but maybe a first timer, right? They said, Aussie, why do you imagine that you are the first person in history of mankind to notice all of these so-called obvious problems with the globe? Are you some kind of super genius?
Yes.
Thank you very much. Next up, remind me a little bit of Jesse Lee Peterson. Let's see. Do you guys know who Jesse Lee Peterson is? You seen him on YouTube?
I'm pretty sure he's amazing.
That's right. That's right. Yes, he is. This is like, it's not for sure yet. And I have to give huge credit to Steve McRae, who might have like made this work. We're in talks to try to get Jesse Lee Peterson on. It's not confirmed. So, but it would be really exciting. It might happen next week. So that is, we're hoping
Wow.
that would be fun.
I've seen him
I've heard
on
of that guy.
Destiny's show.
Yeah, that's right. Destiny. Yeah, they've had a good conversation. Yeah, he's a funny guy. Let's see.
Yeah.
Stupid Horror Energy, thanks for your super chat. She says, James, oh gosh, I don't know if I want to see this. James invited me to sit down. My eyes darted from his, oh my gosh, to the beautiful scenery behind him back and forth. Man, what is with you tonight? Okay, so thanks so much. We appreciate you all being here, folks. Even the sickos like Stupid Horror Energy and Steven Steen. It's always fun. So I want to say thanks so much. We hope you have a great night, folks. It's always fun. Tomorrow there is a tag team debate on God's existence. T-Jump and Amy Newman will be teaming up against 2 theist guests, Sterling and Canadian Catholic. So it should be fun. But last of all, just want to say thanks so much. Flat Earth Aussie and Planner Walk. It's been a pleasure, guys.
Thanks, mate.
Same here.
Take care, everybody.
Thanks, Planner.
Be healthy. Be safe. Have a great rest of your day.